All right, guys. So we're on 4.6, writing rational functions. There are a couple things that we're going to focus on while writing the rational functions. And hopefully, as we go through this, some of it will make sense and you'll be like, oh, okay, cool. So to begin with, we're going to talk about just the attributes and being able to analyze a graph, okay? So we're going to start here with this rational that has a couple discontinuities. Okay, so as you look here, domain, your domain is asking from left to right, where does your function start and end, right? So from left to right, when I'm looking at this graph, I'm reading it. My graph starts at negative infinity and it works its way up until -1. And then it goes from -1 to, stops here at 1. And then it goes its way all the way to infinity, right? So my domain has discontinuities that cause it to stop. So it's all real numbers, but x cannot equal -1 and or +1. Do we see that? Okay. Your range is from bottom to top. So as I read, I'm going from negative infinity. Oh no, I gotta stop at +2. I'm going. Oh no, I gotta stop at what? 3. And then I keep going, right? So my range is all real numbers except y cannot equal 2 or 3. Okay. Your vertical asymptote, remember vertical goes up and down, vertical leap, right? So we're going up and down. Our vertical asymptote goes through -1. Your vertical asymptote goes through the x-axis. So we write it as x equals -1. Horizontal goes left and right, the horizon, right? It goes through the y-axis. So we write it as y equals 2. If I have a horizontal, I will not have a slant asymptote. So that would be in NA. Okay? Your x-intercept is where do you cross the x-axis at, and where do we cross the x-axis at? -2. So at -2, 0. Okay? Where do we cross the y-axis at? That's our y-intercept. Or. And do I have any holes in my graph? Yes, I have a big fat hole right there. There's a hole in my graph at 1, 3. Okay? How do we feel so far? All right, so that's analyzing the graph. What are your questions, comments, concerns about analyzing the graph? None? Okay, then the next part. The next part is creating your function. And I think for our class, I didn't emphasize this much, but your attributes are part of how you create your function, okay? You're going to have to, identify where your hole is, where your asymptotes are, vertical and horizontal, and where your x-intercepts are, all in your function, okay? I'm almost 100% that I told y'all the wrong thing on Friday. So whatever you have written on your paper is wrong. Like I feel it in my spirit that I told y'all something that I can't really tell you what it was, but I know that I probably told you the wrong thing. And I'm being recorded. So this is me being like full transparent that I'm pretty sure I told you the wrong thing on Friday. So let's correct it and pretend that we didn't learn that, okay? All right, so the first thing you want to do is identify your your horizontal or slant asymptote. And where is that at? Y equals 2. The value of that is going to go in your numerator. Okay? The second thing we want to identify is our hole. At what x value created our hole? Our hole is at 1. What factor will give x equal 1? X minus 1. Because it's a hole, it has to be in the numerator and in the denominator. Okay? The next thing we're going to do is identify our intercepts, our x-intercept. Where is our x-intercept at? -2. At what factor would make x equal to -2? X plus 2. That goes in the numerator. And lastly, you're going to identify your vertical asymptote. Okay? Your vertical asymptote is at x equals to -1. That goes in the denominator. At what factor would make x equal to -1? X plus 1. This is the factored form of your rational. okay? It is the factored form because it's in factor. I haven't distributed and multiply. Okay, so to write it as a full-on polynomial in the numerator and a polynomial in the denominator, what would I need to do? Distribute and FOIL, right? Are we comfortable with that? So I'm going to distribute in FOIL. First, I'm going to distribute my 2. Does it matter what order I distribute in? No, it's really up to you. I prefer to just go ahead and get the 2 out the way, okay? So I have 2x minus 1 times x plus 2, and that's going to FOIL to become, what did I write? Oh, I wrote a 2 and a 1. Thank you. There we go. So we have 2x squared plus 4x, and then minus 2x minus 4. Correct? And the denominator, I just got to distribute, and that's going to give me x squared minus 1. Double distribute with FOIL. So combining like terms, what is my f of x? Let me write it somewhere. We have 2x squared plus 2x minus 4 all over x squared minus 1. And that's what would represent this function. How do we feel? Doable? That's the word I feel like is the best. Okay, I'm going to keep this on the page so that because we have to use this graph to answer questions for number 2. So in case you're wondering why I'm staying here, it's because we need to be able to answer questions for number 2. So part 2 is using this graph. It says, given the intervals where f of x is increasing. So when I read this graph from left to right, at any point, is my cursor going up? Is it? No. So is there any interval of increase? No, there's no interval of increase. Okay. So you put NA or no. All right, what about intervals of decrease? Where do I decrease from? I decrease from negative infinity up until -1, from -1 to, if you want to be very specific, -1 to 1, and then 1 to infinity. Do we see that? So on here, there was no interval of increase, but we did decrease from negative infinity to -1, from -1 to 3, not 3, 1. Correct it. And then we go from 1 to infinity. Okay? How do you feel about analyzing intervals of increase and decrease from a rational? Are we still okay? I don't hear any questions. Remember, y'all are my stoplight. If you don't want to say something, ask something, I think we're green. All right. Here, f of x is greater than 0. So this is asking, when is your function above the x-axis? That's what this inequality is asking. When am I above the x-axis? This inequality is saying f of x is less than 0. So when am I below the x-axis? Okay, because here I'm looking for positive y values, and here I'm looking for negative y values. All right, so let's go look at our graph. When am I above the x-axis? Well, I'm above from negative infinity up until -2, and then from -1 until forever, right? It stays above the x-axis. So I'm above from negative infinity to -2, and from -1 to infinity. And, or, yeah, you can. Yeah, the and, or. All right, next part. When am I below the x-axis? -2 to only x values. So -2 until -1, right? I'm trying to get there. So I'm below from -2 to -1. So that's the inequality. How do you feel about reading the inequality? Okay. Next is just analyzing. It says, what is f of 1? So if I go to x equals 1, what do I get? What is my y? There is none. Why is there none? There's a hole. Okay. If I go to x equals -2, what do I get? Y equals what? At x equals -2, we get 0. Okay. So inside the parentheses says you're looking for your x. What is outside of parentheses says you're giving your x? Outside means you're giving your y. So this is saying when y equals 4, what is f of x? So when I go here, go to y, and when y is 4, what is f of x? 0. So x equals 0. How do we feel? Okay, so let's kind of make a conclusion of what happened. So what we did to summarize our values, to write our function, you're going to have A, and A represents your horizontal asymptote or the slope of your slant asymptote. Not the whole slant, just the slope, okay? Over, and then the next thing we found were our holes. The factor of your holes go in the numerator and in the denominator. After we found the factors of our holes, we found the factors of our x-intercepts. And the factors of your x-intercepts only go in your numerator. And lastly, we found the factors of our vertical asymptote. And that goes in the denominator. And by putting it all together, that's how you get your function. Yeah? I mean, what's a no? You're still lost. Yeah, we just did it. We just summarized it. We're going to go through it again. All right, so we're going to do 4 together. Then I'm going to have you do 5 and 6 on your own. Got it? So let's go to 4. Or 3. I skipped 1. We're going to do 3 together. I need to do a slant example. Okay? So again, what's my domain here? From left to right. We have a couple spots, right? We have a vertical asymptote at x equals 0, and we have a hole here. So my domain is not all real numbers, it's all real numbers, but x cannot equal what? 0 and 4. My range. My range is uninterrupted. My range goes forever to -infinity and forever to positive infinity. It's even defined at 3. Do we see that? Because this 3 is good, even though this 3 is not. So our range is all real numbers. My vertical asymptote, where is that at? At 0. Horizontal asymptote. Because my hole is defined here also. So even though this doesn't equal 3, this value equals 3. Like I still have -1, 3 over here, even though I don't have 4, 3. Y values can repeat, but X values cannot. Okay? Slant asymptote. Your slant asymptote, all you have to do is find your slope of your slant and your intercept. But what's our slope? It's 1, right? So it's just y equals x. X-intercept. Where do I cross the x-axis at? -2, +2. My x-intercepts are at -2, 0, and 2, 0. Do I have a y-intercept? No, I have an asymptote there, so of course I don't. Do I have a hole? Yes, and my hole is where? 4, 3. Okay, now we're going to follow the rules that we just wrote. So writing our equation, we said that our A represents either our horizontal asymptote or the slope of our slant asymptote. What's the slope of our slant? Slope is just 1. Okay, next we're going to identify our holes. At what x value is our hole at? 4, so therefore the factor would have to be x minus 4. Holes go in the numerator and in the denominator. Next is our x-intercept. Where are our x-intercepts at? So what factors make -2 and 2? X minus 2 and x plus 2. Lastly is my vertical asymptote. Where's my vertical asymptote? At 0. Is there any point in me writing x plus 0? So I just write x. This is the factored form of my polynomial. If it's not given to me in the factored form, then I would need to write it as a full-on polynomial. But we're not going to. I'm going to leave you to FOIL on your own because you should be able to do that without me. How did it go? All right. I'm going to pause, stop talking, and let you try this one. All right, friends, here we go. Domain. What was my domain? Okay. Good. There we go. All right. What about my range? Okay. Oh, it does cross there. Forgot the little guy. Because your horizontal asymptote can be crossed if it's gonna cause the rational function to go back towards that direction. It's like a, yeah, I didn't see that guy right there. But it's still a horizontal asymptote. It's just at that one point. Usually at an intercept, whether it's horizontal, whether it's vertical or not a vertical, whether it's a y-intercept or an x-intercept. That's the word I'm looking for. All right, vertical asymptotes. X equals -1 and x equals 6. Horizontal asymptote. Y equals -3. And because I have a horizontal, I do not have a slant. X-intercepts. -3 and 2. Y-intercept. 0, -3. And do we have any holes? No. Okay, so following the rule, your A is going to be your horizontal asymptote. What is our horizontal asymptote? -3. Next, we have holes. And do we have any holes? No. Next, we're going to do our x-intercepts. X-intercepts are, so therefore our factors are, there we go. And then last but not least is our vertical asymptote. Where's our vertical asymptote? And the denominator. And what are the factors? X plus 1 and x minus 6. How did we do? Yeah? Is it doable? Terrible? All right, try again. All right, domain. For domain, x cannot equal what? Perfect. Range. There we go. And then vertical asymptote. -2, horizontal asymptote. And therefore, I don't have a slant. X-intercept. Y-intercept. And then hold. 1, 1. All right. What's my function? -1. X minus 1. And then we have X minus 4. And then X plus 2 and another. What else? That's it, right? Yeah. Okay. I was like, wait, I thought someone said something else. All right. How we do? Doable? All right. The next thing, last thing you need to do is analyzing it like we did before. Same values, just now look using this graph instead. Okay. Okay. That concludes our unit 4. So hopefully this makes it a little more clear and easier for you to finish the 4.5 and 4.6 assignments. Yes? No? Yeah? You have the tool to finish it, right? If not, let me know.